Hello everyone, welcome back to Adrenaline Tutorial Platform. I am Adrenaline, the Bazooka Prophet, and today I'm going to be taking my time to actually take another aspect of calculation from chemical kinetics. And now this video is made specifically for students who are preparing for JUPEB exam, IJMB exam, SAT exam, AP exam, and other A-level exams. Now this question is from one of them. Now listen and be attentive. And the question says the reaction, as you can see, shows an increase in concentration of NO2 by 20 times 10 to the minus 3 molar concentration in 5 seconds. Calculate A, the rate of appearance of NO2, B, the rate of reaction, C, the rate of disappearance of N2O5. Now we'll start with the solution of A. Now, before then, we should want to write the rate of the reaction, the rate of this reaction in terms of the disappearance of the reactant and appearance of the product. As we have it, that rate is equal to, from our previous video, we know that because N2O5 is in the reactant, to take negative sign, and that this coefficient of N2O5, which is 2, will be 1 over 2, change in the concentration of N2O5 over change in T is equal to NO2 and O2 are found in the product. So it will be positive 1 over 4 change in the concentration of NO2 over change in T is equal to plus the coefficient of oxygen is 1. So there's no need for you to say 1 over 1 anymore. Just ignore it. So it will be change in NO2 over change in what now? T. Now this is the rate of the reaction. But the question says calculate the rate of the appearance of NO2. The rate of appearance of NO2 is simply equal to change in the concentration of NO2 over change in T, which is equal to, of course, the change here was given to us to be 20 times 10 raised to a minus 3 over the change in time was 5 seconds. Altogether here will give me 4 times 10 to a minus 3 molar concentration per second. Now this is for the rate of appearance of what now? NO2. Take note. Now this is for A. Now to calculate for the rate of this reaction, right? It is simply rate of this reaction is now equal to, now look at it. The rate of this reaction now, of this particular reaction here, is everything that has to do with this part here, which is plus 1 over 4 change in the concentration of NO2 over change in what now? T. Now if you look at on the board here now, we've already done for the appearance of NO2 here, which will have it to be what now? 4 times 10 raised to minus 3. So here will just become 1 over 4 multiplied by 4 times 10 raised to minus 3. 4 cancel 4. It is now 1 times 10 raised to minus 3 molar concentration per seconds. Now this is for the B. Now I'm going to be rubbing this part of the board to create more space to answer for the rate of disappearance of N2O5. So I raise the board. Now I'm not comparing. Now listen, in solving for the rate of disappearance of N2O5, it's just like stoichiometry, whereby you already know for the rate of disappearance or the rate of appearance of NO2 now, of NO2. Ours is to now do for the disappearance of N2O5. Meaning we have to use both of them together. That is how they do it. So it becomes, of course, here become negative 2 change in N2O5 over change in T is equal to plus 1 over 4 change in NO2 over change in T. So the rate of this reaction now, we've already gotten it. The rate of this reaction of NO2, we have it here, which will now be N2O5 over change in T equal to 1 times 10 to the minus 3, because we've already done it here, right? Now, remember the question says rate of disappearance, meaning you are looking for the disappearance of this one, not this coefficient anymore, not the rate of the reaction. This is for the rate of the reaction. They're asking for the rate of disappearance. So meaning you just have to, here become over 1. These two comes to multiply it here. Well, if you multiply, these two comes to multiply it here. So you now be having it to be negative change in N2O5 change in T is equal to 2 multiplied by 1 times 10 to the minus 3. Final answer becomes 2 times 10 to the minus 3 molar concentration per second. So the rate of disappearance of N2O5 is this, but the rate of the appearance of NO2 is this. And this marks the end of this video. If there's any question, do it to comment below and I will respond to it swiftly. Thank you and God bless you.